and welcome to Teacher Gimbal channel. Today we'll be going over Illustrative Math, Geometry, Unit 1, Lesson 18 practice. If you like this video, please make sure to like and subscribe somewhere over in the other corner. And then also, if you want specific videos towards something you need or topics you particularly need help with, if you subscribe to my Patreon, for a cheap monthly price, I can make you any videos that you want on any math topic that you need, or we can do tutoring as well if that's something you'd be interested in. All right, let's get started. Problem 1, and you can find the link to my Patreon in my bio. The figures are congruent. So figure 1 is congruent to figure 2. Select all sequences of transformations that will take figure 1 to figure 2. So congruent in layman's term basically means the two shapes, they're the same shape, they're the same size. It means all of the angles are the same, all of the sides are the same, or that we could have rigid motion that brings one shape to the other. And that's what we're doing in this case, or sequences of rigid motion. So we're trying to figure out which sequence of rigid motion or transformations will bring one to the other. Translate by directed line segment AD. Directed line segment AD is going to look, well, still didn't work. From A to D is going to look like this. Well, if it brings A to D, the same directed line segment will bring B to E, and it will bring C to F. So yes, this works. Let's look at the next one. This does work. Rotate 180 degrees around point E. So when we're looking at rotations, we're always looking for three things. One, the direction. When it's 180 degrees, we remember the direction doesn't matter because it's actually the same thing, whether we rotate it clockwise or counterclockwise. 2, the angle measure. And 3, the point we're rotating around. Well, if we're rotating figure 1 around point E, 180 degrees, we're going to bring it all the way around, which means B is going to get dragged all the way here. And we're going to end up something like this. That does not bring figure 1 onto figure 2. So we cross it out immediately and go on to the next one. C, translate by directed line segment AE. So we're going to translate it by this line segment, which is going to bring the triangle right about over there. Remember, always bring your points with you. And then reflect across AC. Well, if we reflect across AC, it's going to come down there somewhere. So nope, that doesn't work. Next one. Translate by directed line segment CE. So we're going to drag the whole triangle down there, which is going to bring it somewhere over here. We always bring our points with us. Never forget that. And then we rotate 90 degrees counterclockwise around point E. So we have a direction, we have an angle, and we have counterclockwise is this way, which is going to bring CB to stand up right there and pull the rest of the triangle like that. Nope, that does not work. So we cross it out. All right, next question. And with rotations, I always like to rotate a line, and like the line's going to pull the rest of the triangle with it. Rotate 180 degrees around point C. We have point C. We're rotating 180 degrees, which means let's look at CB. CB is going to go 180. He's going to line up right there. So we're going to have CB prime. The rest of the triangle is going to come with it. So nope, the rest of the triangle is not going to go there. It's going to go up here because this line got pulled all the way down there. And then A is going to go all the way up there. And if you have trouble with me doing rotations off the top of my head, I would recommend you finding a piece of tracing paper and check these out for yourself. And then translate by the directed line segment CE. So CE is going to be this, which is going to bring the whole shape down to right there. So C is here, B is here, A is over there. And then we're going to reflect across segment EF, which is right here, which stacks them up. This one is good. And then last one, reflect across segment AB. So we're going to first reflect across AB, which is going to bring us somewhere looking like this. A and B are staying. C is going to go over there. And then we're going to rotate clockwise by angle BFE using center F. So we have center F, which is right here. We're going to rotate by angle BFE. BFE is a 90-degree rotation, and we are going clockwise, which is going to, I believe, bring the triangle down something to kind of like that. It might be angled a little bit more. and then reflect across segment EF. Well, the reflection, I think, so here, if we reflect across EF, it's going to get very close. And I'm doing estimates, but I'm noticing my estimates might not be good enough because we're so close. So we're going to do a little more careful rotating and reflecting. So let's go down just a little bit. We're going to start by reflecting over AB. So what does that look like? So we have AB right here. This is one diagonal, so C is going to be C prime. In this case is one diagonal down. This is two boxes, so it's actually going to line up just like that. And now we're going to rotate over BEF, which actually is a 90-degree rotation. So this pink dude is going to rotate and line up right here. And we are going to look like this, with our A has come over here and our B has come down there. And then we're reflecting across segment EF, which brings this shape onto this shape. So this guy does work. So if you ever come to a point where you're kind of trying to estimate, so I like to estimate it first, because usually I can cross out an answer and say this shape's way far off. But once I see it's getting pretty close, I then want to go ahead and make sure that I'm doing my transformations correctly to make sure that I'm actually checking it in a way that is legitimate. And in this case, by checking it rather than estimating it, I went ahead and I saw actually this one did work. All right, let's go on to the next question. Problem 2. I'm going to zoom in for this one. Maybe I won't zoom in. Oh, there we go. Draw the image of figure ACTS, so ACTS, after a clockwise rotation around point T. So clockwise means we're going this way, around point T, using angle CTS. So CTS is a 90-degree angle. And then translation by directed line segment CT. So we're using angle CTS, which looks about a 90-degree angle. When we're rotating around T, well, this guy, TS, he's going to come slide over here. My S is going to come over there, which is going to pull the rest of these guys. C is going to pull over here. A is going to go over there. So we've rotated 90 degrees using angle CTS, and then the translation by directed line segment CT. So that means we're going to move that far to the right. So I'm going to change colors, and we're going to take everything and we're going to shift them that amount, each point about that amount to the right. And then it's going to bring us A prime, C prime. Describe another sequence of transformations that will result in the same image. So we're going to come up with a sequence of transformations that's going to bring this guy to that guy. Well, let's erase what's in blue so we can see kind of our image and our pre-image more clearly. So if we wanted to talk about a sequence of transformations that brought this to here, well, what I would do is I would probably rotate around point T. I would rotate him 90 degrees counterclockwise, so he landed on his side. I would then translate him, so T goes to C, and then this would go up here. So then he would line up looking like this, and then I would reflect him around C prime to T prime to have it all line up, and it will result in the same image. And there we go. All right, let's go to the next question. Problem 3. Draw the image of triangle ABC after this sequence of rigid transformations. Reflect over line segment AB. So we're going to take this, we're going to reflect C over, which is going to bring C right about over here. We're going to call him C prime. And then we're just going to connect the points. A and B stay on the line of reflection, so they're going to stay where they are. Now we want to translate by directed line segment U. So we have directed line segment. Let's change colors. That's U, which means at each point, so A is going to go right about right here. So A prime is going to end up over there. C is going to shift the same amount. So C double prime or C prime. And then B is going to do exactly the same thing, and he's going to come right over there. I'm going to call him B prime. We're going to connect all those 3 points, and we have translated this shape over to that shape. And if we had done it more neatly, they would be exactly the same shape and size. This would come straight down. Again, I always recommend you using rulers, measurement tools, or tracing paper when you're doing this on your own. I'm estimating it on my screen because that's the tools that I have at the moment. All right, let's go on to the next one. Describe a transformation that takes any point A to any point B. So B could be anywhere. Let's put B all the way down here. Well, I would say draw AB, construct a perpendicular bisector, and reflect A over the perpendicular bisector, and it's always going to line up on B. And we're done. Let's go on to the next one. Triangle ABC. Now, if you had more questions on that, if you go to Unit 1, Lesson 17, which I've already posted, you can go ahead and see a longer description of exactly that problem. Triangle ABC is congruent to triangle A prime, B prime, C prime, which means this guy has a sequence of rigid motions that brings him to that guy. And we've got to describe them. Now, what I'm going to do here, and this is what I like to do in questions like this, sometimes I don't always immediately see exactly like how everything's going to line up. So I'm going to say C, and I'm going to say I know C has to go to C prime. So I'm going to translate by the directed line segment that I just drew, which is going to drag this triangle exactly at the orientation that it's at, kind of up over here. So C is going to go over here, B stays over here, and then we're going to have A over there. We are then going to rotate this much, and let's estimate that and say it's about 15 degrees. We're going to rotate 15 degrees, which direction? Counterclockwise, around point C prime. We're going to rotate 15 degrees, and that's going to line up this triangle. Let's draw him in blue. Hopefully this doesn't get too confusing, right about over there. And the last step is I'm going to reflect over line C prime, B prime. My A comes down here, which is going to take this blue guy and drop him directly on top of A prime, B prime, and C prime. So you can always drag corresponding points, do a little rotation, and a reflection if need be. And sometimes you don't need to even reflect. You can just do the rotation. And we're finished. Take a second to pause or rewatch this if you need to write this down. Problem number 6. A quadrilateral has rotation symmetry that can take any of its vertices to any of its other vertices. Select all conclusions that we can reach from this. So we have a quadrilateral. I'm going to draw 2 different types of quadrilaterals. We could draw a boar. We could draw something like this. But each of his vertices are going to line up with the other vertexes, which tells me that if this guy has rotational symmetry to that guy, to this guy, to this guy, and then back to the center, all of these angles are going to have to be the same measure. They're all have to be right angles. And then this side, he's going to go from this side to that side to this side to this side as we're rotating. So the side lengths are going to have to be the same. So now that we know that this is true, let's look at our answers and see what matches. All sides of the quadrilateral have to be the same length. Yep. All angles of the quadrilateral have to have the same angles. Yep. All rotations takes 1/2 the quadrilateral to the other half of the quadrilateral. This is going to take this guy over here and this guy over there. I don't think 1/2 is going to the other half, so I'm going to cross them out. And that's it. Let's go on to the next question. I expected more answer choices on that one, if I was being honest. Problem 7. A quadrilateral has a line of symmetry. Okay. Nope. That guy has a line of symmetry. He could fold over onto that side. Select all conclusions that must be true. All sides of the quadrilateral must have the same length. Nope. That's not true in this case. All angles of the quadrilateral might have the same measure. This guy's a quadrilateral. He has a line of symmetry. So nope, the angles are not all the same. 2 sides of the quadrilateral have to have the same length. Well, this side is going to have to map onto that side, and this side would have to map onto that side. So yes, 2 sides are going to have the same length. 2 angles are going to have the same measure. Well, if this is reflected onto that, it would have to have the same measure. If this reflected onto that, it would also have to have the same measure. No sides of the quadrilateral have the same length. No, we just determined that at least 2 have to. And no angles have the same measure. No, we know that we're going to have some angle that has the same measure to have that symmetry. So the correct answers are C and D. And as I constantly say, always draw a picture and a couple different pictures if you need to see if you can come up with a counter example, because it always helps when you can visualize a question. Problem 8. Which segment is the image of FG? So we're talking about FG. When rotated 90 degrees clockwise around point P. So our center of rotation is P. Clockwise means we're going this direction. I'm going to look at, we're going to draw the line from the center of rotation. He's going to rotate 90 degrees, which means our line's going to go here, and then G is going to get dragged to here, and then F is going to get pulled all the way over, and it lines up with AB. AB is the image of a 90 degrees clockwise turn around point P. And if you're having trouble with that, pull out your tracing paper. Problem 9. Which statement is true about a translation? A translation rotates a line. No. A translation takes a line, to a parallel line or itself. I think that's the correct answer. And we're going to draw this, but we're going to look at our other answers first. C. A translation takes a line to a perpendicular line. If I translate that line and say I'm translating them over here, there is no way that's perpendicular, so nope. A translation dilates a line. No. A dilation dilates a line. A translation is always going to retain the slope of the line. So if he's getting moved, the slope's going to stay the same. And when the slope's the same, you end up with a parallel line. If I'm translating, say, by a directed line segment here, this line, he's just going to shift up and he's going to end up on the same line. So it's either parallel or it's on the same line that the original image is on. And that makes B the correct answer. All right, if you have any questions, please post them in the comments below. If not, make sure to like and subscribe, and I'll see you in the next video.